Hey students, this is lesson 142, fitting lines to data. There's going to actually be two parts of this lesson. We'll call this one lesson 142A. And what we're going to try to do is, if we notice that a relationship seems linear, we're going to learn how to write equations to represent that and maybe make some predictions with that. All right, so if you just look at this example real quick here, some students were doing an experiment in science class and they were trying to see how far the wagon would go according to how many revolutions the wheels made. And if you look closely here, you'll notice that the dots seem to line up. And if you just look at that real quickly, you probably say, hey, those are lining up in a linear way. And in fact, they are. And a lot of times when we take data in the real world and we collect that data by using some method, our methods aren't always accurate, and so it's just off a little bit. But we can see that this probably would be a linear relationship here. So that's what we're going to attempt to do, is see if we see a linear relationship, and if we do, try and come up with an equation that somewhat models that relationship. So here we have a situation where we have breaths per minute and heartbeats per minute. And if you look closely, you'll notice that as the breaths per minute go up, the heartbeats per minute also go up. And if we were to graph that situation, so all that data, it looks like this. And if you look closely there, it kind of looks like a line. And the line maybe looks about like that. All right. So what we're going to do here is I'm going to draw a straight line through this, not so thick though. So I'm just going to draw a straight line through here that seems to approximate the slope. And what I'm going to do is kind of first get the slope of the dots. That would be about like that. Okay. And then I'm going to move my line inside this, so I kind of split them up so I have about half of them above the line and half of them below the line. All right? And then we're going to write an equation of that line. To do this, we need to know what the slope is, and to help us find the slope, we can really use any 2 points to get the slope. So what I'm going to do is either find 2 points that are right on the line, or find 2 points that have the same slope as this line. Okay, so I'm thinking like maybe right here and right here. Those 2 points seem to have the same slope. It's kind of dangerous to get two that are right next to each other, though. You could kind of get off. But maybe also, I don't know, this one looks pretty good and this one looks good. So this point here is at 15 for the breaths per minute, and this one here is at about, it's like about 34 breaths per minute. So 15, actually it was 16, and it was the lower one of those two, so that one's that one. And the 34 is this one. So I'm going to use those points to come up with my slope. These are going to be my y values, these are going to be my x values. So I'm going to do 94 minus 57 for my y values, and 34 minus 16 for my x values. So I get 37 divided by 18, and that is about, I'm going to round that a little bit, about 2.1. So that's what I'm going to use for my slope. All right, now I need an equation, y-intercept, and I'm just going to pick, well, those points, it looks like the line goes right through those points. So I can just use one of those points to help me get my y-intercept more accurately. You could just guess what your y-intercept is. Like from this, it looks like it's about maybe 16. But it might be a little more accurate to actually use one of those 2 points to help us get that y-intercept. So when x is 16, y has to be 57. So remember, my equation is going to look like this. 2.1 times x plus y-intercept. And we know that when x is 16, y is 57. So when x is 16, so when to multiply 2.17 times 16 and add a y-intercept. It has to equal, what is that, 57? All right, so I'm going to multiply 2.1 times 16. And that equals 33.6. 33.6 plus what number? That's equals 57, so I can just subtract 33.6 from 57, and that's 20.4. So that's my D. All right, so now I have my equation, which is 2.1x plus 23.4. Now you might wonder, well, big deal, why do you have that? Well, if we want to figure out a person, like maybe we want to know what their heartbeat would be based on their breaths per minute. Like let's say we found that they maybe were at 25 breaths per minute, and we wanted to know what their heartbeat was for that. Well, we could just take our equation now and do 2.1 times 25 plus 23.4, and that would give us the answer. And on my calculator, I get that equals 75.9. So notice we got a number 75.9, even though that wasn't even on our table. So we came up with an equation that models the situation. And the word for that is interpolation, when I find an answer of something inside my data like that. All right? One technique for improving the fit of your line is to use the means of the data. And I'm going to show you how to use the means of the data on another problem on page 11. So go to page 11 here. Right here. So here we have some data. This scattergram shows a relationship between the minute study and your grade. And what I'm going to ask you to do is go ahead and create the graph for this. So go ahead and plot those points on your graph. All right, so we're going to come up with an equation for this one, but to do that, we're going to use the averages. And one reason you use averages is because you know that that point should be consistently report what the middle of this data is. Some things can mess up the average though. Outliers can mess up the average. And you might notice these points way out away from the other points. To help us with this, we're just going to eliminate those 2 points. And then I'm going to find the average of this data. So what I did is I added up without those 2 points. I added up all the data, so I got rid of this one. And I got rid of this one. Okay. So I added up all the minutes studied divided by how many there were. And I got 62.5. And then I did the same for the grade. And I got 63.125. So I'm going to put that on the graph now, 62.5 and about 63. So I'm thinking that's about right there. So that red dot is my averages of the data. Now when I put my line here, I want to make sure it goes through those. So we can see the slope of this line is about like that. And then I just want to make sure it goes through that line, that average. And I can see I go through a couple other points pretty good. So if I want, I can use, and I want to use my average in my data. So I'm going to use my average, and I'm going to use this point right here. I'm just going to round this to 63. So the points I'm going to use to get my slope of this line are, I'm going to use this point right here, which is 40, and then I'm going to use my averages. So I'm going to take 63 minus 40 divided by 62.5 minus 40. And I'm going to use that for the slope. That equals about 1.02. Now that I have that, I can choose one of those 2 points to come up with my equation, use that to get my So my slope of my equation is that 1.02. And now I just have to find the y-intercept using my 40/40 or my other point, 62.5, 63. All right, that's going to be it for this video, and I'll see you tomorrow.